All right, let's kick it off. Thanks for joining us today. My name is Stefan Hof. I'm manager of technology with Exclusive Networks, and I'm not alone here. I got a colleague, Davey.
Hey, good morning. So I'm Davey. I work in Stan's team. I focus myself most of the time on emerging, what we call emerging and new vendors and technologies. Basically means that I spend a lot of my time in looking into what cybersecurity market is doing, how adversaries behave in different environments, and then yeah, get a deep dive in there and try to use that info to help our partners and their customers in doing the right thing in cybersec.
All right, so topic of today is cloud adoption and security. And let's talk about this because, to be fair, we're all from the more traditional cybersecurity approach, and cloud security is something entirely else. So why are we moving to the cloud? That's a very good question. Cloud journey started for a lot of companies already many years ago, and especially in the beginning, it was all the good news show, right? If you do it well, it's very flexible and you can scale. So it's important that if there's a need to scale, you're able to do that. And then the custom optimization, of course, you're not having that upfront cost anymore, but on a monthly or yearly billing system. And it's easier to go to market. You're more agile. It's easier to look forward to new technologies and to adjust quickly. If you do it right, security and compliance, if you have a modern application approach, it's easier to check out controls and to have continuous compliance and overall global reach with data centers all over the place, especially if you're an international company. It's easier and it's maybe even cheaper if you do it good. Years ago, a lot of companies went to the cloud, but it was more like a lift and shift approach. They were like on the end of the life cycle of their hardware on-prem, and they thought, well, let's use a cloud because it's fitable, scalable, and it has a lot of benefits. So let's do that lift and shift of our current environment. And the whole idea was we have a low upfront cost, which is great, and infinite amount of resources, so we could do a resource boost whenever necessary. But essentially, it's all wine in new bottles because we didn't do anything about the application itself, which led to a lot of companies coming back from the cloud because it wasn't cheap at all. If you don't use the scalability that the cloud can offer you, it's not the best approach. So what you should have done, or are you doing at this point, is that you're actually modernizing your applications, making it cloud native. There's maybe a misconception. Cloud native doesn't actually mean that it runs in public cloud. It can still run on-prem, of course, in a Kubernetes environment. But the whole idea is that you have a different build-up of your application, so it's scalable. When necessary, it can spin up more workloads. And by scalable, by default, it might be interesting to go to public cloud. Not only that, but if it's a new application, it also supports smaller application like XAML and OAuth. So if you want to move to public cloud, you have to invest in a lot of things. And one of them is a different skill set. Again, we will going to talk about it closely is networking. It's completely different in the cloud than we have in an on-prem environment, but also different skill sets and also requires different tooling. We need to invest to see that we have visibility, especially if you go multi-cloud. And we have new attack vectors, of course, especially in the beginning, in the early years, everything in cloud was publicly accessible by default. Luckily, a lot of those cloud service providers, they're now doing the least privilege and they lock down everything by default, so that's better. But we have new attack vectors, but also old attack vectors we're going to talk about. But if you do it right, and like again, we said with a modern application and you have the good use case, also very important. The cloud is very good for scale. So if you have a scalable application and that needs, moving to public cloud makes a lot of sense. Although there is a lot of people that thought, let's move to the cloud. In that way, it's not my responsibility anymore. Fortunately, that's not the case. For some solutions, it was beautiful. For example, I in previous life, I managed Exchange servers on-prem. It was a nightmare to keep up to date. That's a beautiful example of going to Office 365 and moving that to a SaaS application, where I don't need to focus on the operating system or the application itself, only in how to configure it and who has access to what mailbox and that and also the security over that mailboxes. That was my responsibility then. That's a typical example of SaaS solution. But if you go to infrastructure as a service or platform as a service, you have some more responsibilities that's also for you and not for the cloud service provider. And especially if you look at the networking level, depending on which type of cloud service provider you are using, it's a different approach. So the layer 2 and layer 3, as we know it, is not the same anymore. Hence the different skill set that you need to learn how to actually configure this well, so you don't accidentally open up your resources publicly, but also you don't have visibility of what developers are actually doing to make sure that it still passes your cloud firewall, for example, not going directly outside your network. So the cloud networking is actually essential for modern businesses. They help you enable to leverage technologies like containerization, serverless computing, and microservices without the typical infrastructure issues that you had when you were on-prem. It helps facilitate better collaboration for remote workers and global teams and allow access to those applications itself from anywhere. And again, supports those rapid application developments. So to do all that, we needed new tools. For example, our cloud firewalls, which is actually a comeback of maybe the next-gen firewall. So some people thought the firewall was dead, but it finds a new role actually also in the cloud. It helps with scalability and availability. You don't need to, if you configure it right, it's available at all times, and it can scale if the load gets bigger, but it's essentially it's very good because it gets closer to the assets, which is good for network performance. And we can enable some security features on that network traffic, because that is not the responsibility of a cloud service provider, that's your responsibility. With a public cloud firewall, it's very integrated in that specific CSP, and it also makes it possible for microsegmentation, for example. It's perfectly to keep those DevOps contained.
I think that's also it's a good thing to keep in mind that the evolution that we've seen on getting public cloud firewalls into, if we go back a few slides here, if going back in this network layer, there's definitely been a lot of evolution in getting like next generation firewalls in there. What you probably all know is that these providers provide their own kind of, let's say, limited firewall approaches but of course, I mean, with let's say the luxury of having a next generation firewall and over the past years and seeing that evolution, it makes sense that customers wanted to put this same technology also in their cloud. And that's how, the providers for cloud actually followed along with how the market evolves, how cybersecurity dictated, like, hey, this is what customers want, what they need. And you see this evolution where cloud firewalls really have found their place into the virtual networking into cloud environments, into virtual private clouds, etc. They're on top of the rest there. There's still, if you're looking purely at the networking, there's still VPN, cloud, private access or VNet peering to these environments. There's a whole concept of load balancing, and most of these things are provided and are pretty good by the cloud provider itself. But I think cloud firewalls is maybe an exception, if we can say it like that, where it's where you can really see the cybersecurity market a bit more focusing on or moving towards cloud and putting same technology as we had on-prem or similar technology, but then on the cloud resources. Sorry, I just want to...
No, it's good. It's a good way to adapt to a new world. If you're moving to the cloud, most of the times it gets more expensive than you thought. This nice example is typical in Belgium. This is the train station in Mons that took 10 years longer to build, and the budget increased 13-fold. So typically Belgium, like we say. This is a report from Gartner in at what time that it actually goes off the rails, and the project takes longer to complete, and it gets more expensive. And usually it's because people are rushing too fast, don't make the right decisions, like the wrong people. Like we said before, it requires a different skill set. And they're rushing too hard because they want to move to the cloud by the end of Q or end of year, whatever the goal is. And usually they're getting rushed and they don't do the right analysis. And again, like we said, being cloud native doesn't mean you have to go to public cloud. It means that you have to go with a new approach to building an application. But if you have a very stable workload and it's not necessary to be online or close by from every location in the world, maybe it makes sense to do this on-prem in a Kubernetes environment instead of public cloud. So there are multiple ways how to actually make a mistake in the whole migration, which increases the cost exponentially, but also hidden costs, because at some point you move into a cloud, you still have on-prem and you have licensing for both and stuff like that people didn't think about. And essentially the whole cloud migration was a nightmare. Also for IT admins who are looking for buying new hardware, but everything goes through the cloud provider.
But there's also the skill sets. I mean, you need certain skill sets and you need time to, for example, manage your on-prem environment. But there's, I think in the beginning of cloud adoption, there was like the mistake that, oh, if we go to cloud, we don't really need all those skill sets and that effort. But that's definitely not true, because cloud is a completely different environment, new concepts, different concerns, basically. And I think that the time that we put in managing an on-prem server to run your applications or run your services is now moving to, okay, let's use cloud services, and we're basically rid of those concerns, and we don't need to put effort anymore in learning or managing an on-prem environment. But you're just shifting it to other skill sets that are needed, and the main challenge there as well, I think, is changing on a daily basis, because you're dependent on what the cloud provider delivers. It can be situation A today, and tomorrow they release a new update on the features or the services that you're using, and you need to adapt to it. So it's definitely a shift in skill sets, and shift in responsibilities, and a shift in how you manage or how you deal with these resources. So we talked about cloud, and one of the major things is most companies, when you're looking at their applications, data, and the workloads or basically services or whatever is running, most of the time what we see is that there's a mix in an on-premise and cloud deployment. So this stuff is basically mixed in or running in both environments. It makes sense because companies came from an on-prem situation, and they might have started adopting cloud, and they end up, most of the time what we see, they end up in a hybrid. Hybrid will there's statements that hybrid will be there for a very long time and maybe forever. Maybe some companies can go full cloud, and still there's always a reason, or there's always some dependency on why you would go also on-prem. We got examples of startups that started completely cloud only, cloud native, and then after a year they decided they needed some on-prem stuff as well. And it could be all kind of reasons: cost of things, access to certain resources, maybe just compliancy or privacy, that they don't want to put their data somewhere. So there's definitely reasons, but hybrid also means that sorry, the user really the user really needs seamless access to everything, and they don't want to authenticate 5 times to get to certain applications, because it's a mix between on-prem and cloud. So it needs seamless access, single sign-on experience, which actually means that hybrid cloud leads to what we call hybrid identity, because identity is basically the thing that is gluing all these on-prem and cloud identity stores or IAM infrastructure together. It's identity that will decide if you have access to the applications or the data. That's the only real way to support modern and legacy applications is in a hybrid environment. The challenges here are of course, different than when you have an on-prem environment. There's first to start with, the security parameter as we know it has clearly dissolved. That means when you have an on-prem environment protected by firewall and access to network, and of course still authentication from a user, now the whole thing is just publicly open, and identity is basically your only way of really securing it. It's a new front line of cloud security, and that's why you see a lot of statements where they say identity is the new security parameter. Having cloud resources means that also a serious expand of your attack surfaces. Think about if you have an on-prem and you extend it to cloud and basically linking environments together, then of course it makes sense, and it's realistic that the new attack surfaces are appearing on this. And credentials is a very big aspect there, or identity basically in general. as an attacker, and that's what we'll see later as well when we walk into some trends in cloud compromises. But as an attacker, you don't need to wait for exploiting the new zero-day vulnerability in some kind of app to get access. You can just take the credentials and log in, and that's what attackers most of the time do. If we're looking at cloud compromises, they find a way to get credentials and then they just use them to log in. No need to go and blast a hole in the wall. If you could just open the door with whatever key you have, doesn't matter who you are. If you have the key, you can basically open the door. There are some nuances here because if you do it right, you could limit who's capable of opening the door when you have the credentials. Think about conditional access, for example. But basically, credentials is very big thing. If you have them, and you can see that as well in adversary trends, if you have the credentials, this is if leak credentials that get stolen, then you're basically in trouble. In, let's say, our market, or the way the customers and the parts that we talk to, basically in the region, I think it's fair to say that we're all using Microsoft. We're coming from a Microsoft Active Directory environment, and I think most companies, we don't really have numbers, but most companies are really expanding it to Entra ID as well and have a hybrid setup. Hybrid setup means that it is basically a synchronization between your on-prem environment and your on-prem Active Directory and your cloud Entra ID directory. It's common to integrate this on-premise infrastructure because you want, like we said in the beginning, you want to allow your applications to be accessible on-prem and cloud, and you want to have the flexibility of where you're going to deploy them. So there are some different concepts, of course, when you do this. To start with authorization, there's different concepts of between an on-prem Active Directory and Entra, right? The boundaries of the security are different. For example, in an on-premise environment, your boundary is the domain. In Entra, the boundary is a tenant, where it can have multiple domains. So there are different concepts. There's permissions and roles that are different than what we have on an on-prem Active Directory. There's a different way of interacting with on-premise systems where Entra is API based and uses tokens and uses protocols like OAuth and SAML. But on-premise is different. There we talk Kerberos and NTLM. So authentication is complex. The classic approach there is passwords. And with the synchronization, there's password hash, there's password authentication that is capable, maybe federated authentication when you're logging in. But users want, again, seamless sign-on, but they also, as a security admin or as an Entra admin, you want to use the modern capabilities as well. You want to use FIDO2, you want to use Windows Hello for Business because it's easy. But if a user authenticates to a system through Windows Hello for Business, then they don't want to authenticate again because they need to access, let's say, a file share, or they want to access their email. They're logged in, they want to be able to continue. So there's always a balance there between user ease of use of systems for the user, but also security, and that's definitely also where conditional access comes in. Looking at this, you might already see a bit like the challenge, like how we combine modern protocols like FIDO and OAuth with the legacy stuff let's say the on-premise stuff like Kerberos, and that's a challenge that we also see, like what Microsoft is doing, where they have the on-premise Kerberos, because Active Directory speaks Kerberos and NTLM, although NTLM should be moved out, and they're trying to phase it out. It's not a simple thing, but there's a lot of work being done on that. Kerberos is the primary authentication protocol, but it's not going to go away anytime soon. It is really baked in a lot of applications, and it's not like what Stan just said in the beginning, like lift and shift to the cloud and drop it there. You could do that, but you're basically just moving your network and your resources away from one space to another. That's not really cloud adoption. But if you really go into the cloud, you're facing a bunch of new protocols, and how you're going to adjust your legacy applications. So Microsoft understood that when they have Azure AD, and now it's called Entra ID, that they had to make some changes to support legacy stuff, and that's why they introduced a bunch of features called like Microsoft Entra DS, Cloud Kerberos Trust, Microsoft Entra Kerberos, pretty recently. Let's say last maybe 2020, 2021, I think, where they actually introduced this to expand Kerberos based to Entra because they had no choice. It was necessary to support these legacy applications, and Microsoft delivers, right? If the customer needs it, they're gonna bring it on to keep these customers into well, happy and make sure that they keep moving to Entra and adopt Entra more than they focus on their on-prem AD. So you can see this as a store as a sort of extension to Entra. There's actually an interesting use case why you would do that. We just want to dive in briefly because it will show you like the security implication that something like this has when a legacy goes to a modern approach. Think about having a Azure virtual desktop, like a Windows in Azure, that you can use with multiple users. Let's say that Stan and I will log in on that, and if Stan logs in, he wants to have his desktop, he wants to have his file shares that are mounted, he wants to have his icons, shortcuts, whatever. And I want mine. Typically the same as you logging into the classic terminal server approach on on-premise, or you're logging on multiple machines in a network. There's basically your profile gets loaded on that system. The system responsible for that is FS Logics. Basically loads user profiles onto the system when you're logging in. Where do you get those user profiles? They're actually hosted on a file share, right? And Azure has Azure Files, and Azure File Share supports SMB because that's how this thing is loaded. So that all looks fine. The only question there is like, if you have an Azure Virtual Desktop in Azure, a Windows machine, not linked to an Active Directory, it has no line of sight of your on-premise Active Directory, how are you going to get SMB access to a file share? There's no Active Directory. There's no way of giving you what is called a Kerberos ticket to actually get to that SMB file share. It's a problem that occurred a lot, and Microsoft brought a solution in different ways. If I go back, if you see here, you could solve this with the Entra DS, but that's a lot of infrastructure to deploy. So they brought a different solution, which is Microsoft Entra Kerberos, and they basically ported or took Kerberos and also put it on Entra with some security improvements for sure. The major thing is that they have now a cloud TGT instead of a normal TGT. TGT is a ticket granting ticket. Basically, you're like you as a user proving who you are to the Active Directory, and then you can ask tickets to speak to different services. Now they use a cloud TGT for this. We're not going to go in detail, but the idea here is that basically your virtual machine, your virtual desktop, has no clue that it has no Active Directory inside, and still it gets like a TGT because Entra is sort of proxied in between. So it's a very neat solution and a very useful solution for a lot of customers for sure that using Azure and then using these services by Azure. But as we said, it also brings security risks. There's actually an analysis of a research at Silford who looked at the pass the ticket and silver ticket attack on an on-prem Active Directory. These are attacks that are already known for a very long time, where you can reuse tickets to then claim that you're a user. You steal the tickets from memory and then use them to access services. And they were able to do exactly the same now with this Microsoft Entra Kerberos. They named it bounce the ticket and silver iodide attack. But basically, the bounce ticket allows you to reuse that cloud TGT, similar way as you use the regular TGT on-prem. So by porting Kerberos to Entra, they actually introduced new attack surfaces, and it's pretty similar to the existing attacks that we know on-prem. So I think that's the core message here is that it's not because you go into cloud that you can drop or you can forget about certain attack paths that exist on-prem, because stuff should get ported because it's needed for application compatibility, and then this kind of things occur. This is really just happening all the time. And this is an article from 2023, but we see recent new kinds of things that have been figured out. So definitely an interesting read if you want to know more about that. Another big challenge with cloud is everything related to non-human identities. And this gets a lot of attention recently. A lot of companies are talking about NHIs. These are accounts that are not linked to a person, right? They are basically accounts that are used by, let's say, machines. They are used by automation tools, scripts, even AI agents. First time we say agents in this call, already some minutes in, so that's good. But they definitely use this. Why? These tools also need certain resources, and they need to authenticate and be authorized to use these resources, and they use what is called a service account on-prem or a service principal in cloud. That's basically the concept there to access these resources. Now, according to so for example, there's a ratio of 150 for in terms of service account that exists in a like an average company. That means that for every human being in a company, there's 50 service accounts linked to related. So 1 on 50. That's quite a big number, but it's probably not that far away if you think about how fast it goes in automation, and especially with AI agents, it will go even much faster because these agents need all kind of access. They need to access APIs and they need to authenticate before they can do that. The question is, do we all know which kind of non-human accounts we have in the environment? What are their privileges? Most of the time, the answer is we don't know. But you want to keep an eye on them. You want to see what their activity is, what the accounts used for, especially because you want to know if adversaries are abusing them. These are one of the major things or major issues with identities, especially non-human identities, is that there's not always clear who the owner of the account is. Maybe the owner already left the company and he created a bunch of services and tools that need service accounts or service principals, and they're alive in the environment, and nobody is there to touch them anymore because they're scared they're going to break business. But you need to keep monitoring closely and make sure that their privileges are clear, because if you don't, again, if you compromise identities, you can basically become whoever you want to be. Like the man with no face, I believe, in Game of Thrones. If you have a bunch of credentials, you can just take them and then you can claim and impersonate that user or that user account if it's about a non-human identity. So we talked a lot about identity, right? About cloud adoption, move to cloud for legacy apps. But what about attacker land? So how do clouds get compromised? I think for those who are who know us, they will know that we're a big fan of the MTrans report from Mandiant. And we're actually in the MTrans report of 2025, which was released like a month ago, I think. There's also a lot of stuff about cloud itself, like how is cloud initial infection vectors, what are the trends there? And again, no surprise, I guess stolen credentials, email phishing is like the big chunk. And that cloud is hot is clearly even seen from the table of contents of their paper, because from the 8 articles that they have in there that go on specific topics, 3 or maybe even 4, if you take the data repositories with it, is about cloud. And that means something. That means that adversaries are really focusing on cloud compromise. The attack paths that they have is basically introduced by cloud adoption. Companies go to cloud, new attack paths secure. There are a few key, or there are 3 main ones. Is first of all, integration, like we said, hybrid environments, on-prem cloud. It comes with a lot of configurations, a lot of ways to go wrong, and it just introduces by nature a few attack factors, like it allows vertical movement. If an attacker can compromise an on-premise account, for example, it can maybe create cloud accounts and use that to move to the cloud. That's just the nature of how it is. It allows an attacker to breach the cloud boundaries, right? Where if you have hybrid environments, there's no more clear cloud boundaries, there's no more clear on-prem boundary, and there's different ways of moving between them. For example, if you just lift and shift and you deployed a few VMs on the cloud, they're maybe managed by same tools that you use on-prem, and this way you actually breach the boundaries a bit. But in the attack surface extends, right? Think about your data. It's not publicly accessible for enumeration. If you think about an Azure tenant, you can find a lot of information just by querying public available data to get more info on your domain, get more info on the company itself, the user, etc. It's public available because that's how it's designed. If you have credential leaks, we talked about credentials before. Credentials are leaked all over the place in script repos, etc. Those credentials can then easily be used to go into the cloud. And then publicly exposed services. Like we said, identity is a new parameter. There's no more like VPN focused access to certain resources. It's just logging in to those.
About the enumeration, last year we were on Black Hat and we had an interesting talk that we saw about Microsoft Copilot Studio, which is actually a way for you to build your own AI agents based on your data. And by default, it was also accessible by anyone in the company. So if you were doing the right enumeration, you're able to look at HR data, for example. So again, the enumeration is especially for internal, but also externally, if you don't do the right stuff in protecting all that data, your data is going to be leaked out there. And it's not an exploit, it's not malware, it's just bad configuration and bad practices. That really extends that attack surface, especially with all the AI models getting access to the data nowadays.
That's actually a good one, because the AI is going to make it even much worse. We saw it actually, I think, just this week with the MCP vulnerability on GitHub. We're not going to deviate into MCP, but basically, the GitHub MCP server was, they were able to do prompt injection, which actually allowed, was it Claude, I think, from Anthropic, to actually dump information on private GitHub repos from a user. And even though that private repo is not visible directly, it was exposed because of the implementation of MCP in this case. So it's a different discussion, but it really just shows how new technology extends the attack surface rapidly. So Marion really described that if you're looking at cloud compromise, there are three success factors why adversaries are able to do what they want to do in cloud and compromise environments. It's about identity solutions, surprise, surprise. It's just a lack of good security controls on identity, and a lot of quick wins can be done there. Of course, phishing with an MFA to start with, but also just limiting, like, where are you able to log in. Using conditional access, for example, on Entra allows you to limit who can log in on from which device and from which region, if you know that you're working in that certain area. And attackers, they still might be able to trigger that, to fool like they're coming from another region, but at least it's another hurdle that they need to go over. There's improperly secured on-premise integration. We talked about that as well. On-premise and hybrid environments, they bring new attack paths, and it's a complex environment. And then visibility, logging, and just for threat hunting and incident response, you need the right visibility into the cloud. What Mannion reported is that still a lot of companies don't have enough visibility, or not the same level of visibility in their cloud than they have on-prem.
Yeah, I think a lot of companies are still struggling with visibility on-prem. So let alone thinking about what they have in the cloud.
Yeah.
If developers are putting stuff online, they have no clue.
So that's the three key aspects why cloud is compromise is working for attackers. But it's actually interesting to see how also traditional techniques are moving to a new cloud adoption. Right, you see a little schema or a table at the right side of the screen where it's, for example, where Manuel said, like, where there was an internal reconnaissance SMB scanning in the past, where internal environment was scanned through SMB to find out if there were any file shares. Now what is done with cloud is that there's a cloud object storage discovery. You're looking for S3 buckets, for example, in AWS. Same for exfiltration. They used to have a C2 channel command and control, where you control devices and then you exfiltrate data over, let's say, over the C2 channel in general. That technique in cloud, it doesn't work if you don't have that VMs there. But what they do is they exfiltrate directly to cloud storages. They just dump data into a bucket, for example, a storage bucket that they then expose publicly, and then they can download the data from everywhere. So it's interesting to see how traditional techniques and new cloud techniques basically align, but how there's a change. And MITRE is also has also adapted on this, I believe, in version 16 of the MITRE Tech framework. I believe, 16, in somewhere in October last year. They brought the cloud matrix, where they made a specific sub matrix for the enterprise one, but focused on cloud. And there you can see which kind of techniques are used in initial access, execution, privilege escalation, etc. But then specifically focused on cloud. They even have one on identity, where, because identity is such a big thing, like which kind of identity tactics and techniques are used by adversaries, and who's using them, which APTs. They have other categories like specifically on Office, everything M365, SaaS and IaaS as well. But gives you an idea why identity is such a big thing if they make a separate matrix for this as well.
So you see the evolution, and the MITRE is also following. Same should be done for all the security frameworks. A lot of focus nowadays on compliance, and one of the first thing about compliance is about what Dave also mentioned, least privileged, who can access what, and only that is necessary. So all things about access policies, but also really try to make sure you don't give more rights than necessary for applications and for humans. And we're a big fan of the Zero Trust framework of CISA. So the never trust, always verify. Make sure you also try to implement that in cloud. If you do it in the right way with platform modernization, they also do it from the start with Zero Trust in mind. And the benefit of doing that and with the modern approach is that you can do continuous monitoring of your environment with adaptive controls, which is important in the whole compliance part. Because in that way you can verify your controls continuously, and based on API calls you can actually make sure that everything is set up best practices and compliance to NIST framework, ISO 27001, or whatever framework you're basing on. In that way you can make sure that your developers are compliant and secure, because in reality there will be gaps, of course, and filling those gaps, we have a lot of vendors out there who are trying to do something about that. This is quite overwhelming, but essentially, let's break it down to what we think is most important, or at least we're most comfortable with, because it's getting closer to the traditional security. And one of them is CNAPP, or Cloud Native Application Protection Platform. So it's not just a single point solution. They're really building a platform to have the most coverage for your cloud security environment. And basically are two categories. One is actually making sure that what you put online is secure by nature or by default, and make sure it keeps getting secure, so it gets scanned if there's no vulnerabilities out there, and then interact with that if necessary. But also runtime detection and response comes very close to what we call with our EDR. So instead of EDR, which is traditional, that we know that's running agents on our endpoints and servers, usually running on kernel level, and then getting all that information and hooking into all different processes and executables to have a very detailed view about what's happening on your endpoint. We're now having to have that. We want to port that visibility to the cloud, but it's a little bit different because it's not directly on the operation system. It's based on actually your hypervisor or your Kubernetes environment, and will get as much visibility as possible to have that same level of detection, although it's not on the not as detailed that you can go with EDR tools.
Yeah, that's also what you see in the evolution of the vendors that are now the EDR vendors that we all know, where they're moving to CDR, is that it's a different approach. They need to work through what they can get through APIs. If you're looking at Kubernetes, they work through ePBF, where they can get get the data, or get like the telemetry that they need, that they used to get from an EDR from syscalls from the kernel, for example. Now they don't have that in containers, and also these there's like the very short lifetime of certain containers. Containers get spin up, they run for a minute, and they're gone. And everything that happened there needs to be analyzed. It could be a malicious activity. An adversary is basically spinning it up or modifying whatever that workload needs to do. So in that sense, it's a different approach, but the goal is the same. We want to detect what's going on, respond if anything malicious happens, but there's a different playground, let's say. Same for application detection response, and this is all pretty new, even for us. And then it's actually this slide's a bit of a sneak preview, what we're going to work to in the future, because we believe for sure that CDR still has a lot of growth and still a lot of area to grow in, and we definitely want to keep following up on that as well with our EDR vendors. But the ADR is a new, well, I don't know if I can say it's new, but it's pretty recent approach, because I don't know if you saw it on the previous slide, the developer don't really care about security. They care about getting their application deployed and how performant it is, etc. But they don't care about security. They really don't want to be bothered with it. So all these solutions that try to get into the developers and making sure that they their ID, for example, tells them like you're writing a vulnerability or whatever, that's sort of maybe they're reluctant not to adopt it. They want to go for it, but they don't want to be bothered with it. So ADR has a different approach where it's basically mixing the application development and the deployment phase and try to do detection already on that level when the app gets deployed before it's actually really into the runtime. So I think in that sense, ADR just comes before the CDR, I would say. But just keep an eye on this because we're going to do more about that in the future.
I also think that because all those applications are exposed, they're putting more effort in prevention than they used to do, developers. Not the developers, but the security frameworks around that. They're stress testing the applications. They're doing different techniques to make sure it's not that Swiss cheese with all the holes that's easy to breach. So that's a big improvement compared to application development a few years ago. But of course, prevention is not enough. You also need to work on detection, which is also interesting from a technology point of view. So that's it. Remember, there is no cloud. There's just someone else's computer. And thank you for the attention. If you have any questions, put them in the chat. If not, have a nice day. And thank you for joining us.